This video is a very short introduction to futures contracts. It is intended for people that have never taken a course on financial derivatives. I'm going to follow Hull's book, and these initial chapters are posted in Moodle. Okay, so these files, these PowerPoint slides, are themselves a summary of Hull's chapters, and I think it's probably enough to read the slides only. But if you have any questions, either ask them in class or read Hull's book for a deeper explanation of these concepts. All right, so chapter 1. Please read through this. These are just basic definitions and concepts. There is an important point here, this slide, that tells you the two positions that you can take in a futures contract. You can either take a long position or you can take a short position. And these are the payoffs that you get from either the long position or the short position. Right, so please read through the first chapter. You see all these examples here. All right, let me move on to the second chapter. All right, so in here, let me point you to the following. Here you see typical behavior of the spot price and the futures price. At the maturity of the futures contract, the two prices have to be the same. We call this the convergence of the two prices, of the futures and the spot price. Okay? There is also this effect here before maturity. If you see something like this, where both prices move together, we call this parallelism. Okay, this happens when there is a tight relation between the spot and the futures price. When we get to energy markets, we will discuss which contracts display this behavior and why or why not. We move forward. Please read through all these slides here. In slide 17, there is a point here that is important, which is the following. There are two different types of contracts. Some contracts are financially settled, meaning that they can be settled in cash, whereas other contracts have physical settlement. That means that if the contract is kept open until the end, when it gets to the end, there is physical delivery of the asset underlying the contract. In that case, if there are some alternatives to what can be delivered, it is the short position that chooses what and when to deliver. So that's the end of chapter 2. Let me move on to chapter 3. So from here, let me point an important part here. So slide 8, which is about the choice of contract. So we should choose futures on the asset that we want to hedge, and with the delivery month that is as close as possible to the end of the life of the hedge that we want to do. But sometimes we don't have a future that is exactly on the same asset that we want to hedge. So in that case, what we want to do is we want to find a futures contract that is as close as possible to the underlying that we want to hedge. And that is called cross-hedging. When we have to do a cross-hedging, we have to adjust the amount of futures that we need to trade, because the futures is not exactly on the same underlying as the asset that we are hedging. So this will happen in energy. For example, we may want to hedge jet fuel, but there is no futures on jet fuel. What we have is a futures trading on diesel, and therefore we'll have to do cross-hedging. Okay? So to do that, we first need to determine this proportion H, okay, which is determined by this function here, right? Please read through this definition. And once we have that proportion H, the number of contracts, or futures contracts, or forward contracts that we trade is given by this formula. So these two formulas give you very similar results, but there is a slight difference. So use the formula here on the left if we are trading a forward contract, and use the formula here on the right if we are using a futures contract. The difference comes from this tailing adjustment, which basically means that futures are different from forward contracts in the sense that they have daily settlement. Okay. This is my attempt at giving some intuition for where these formulas come from, but the formal, more rigorous proof is done in Hull. Look up the book for the formal proof. Okay. There is this example here that is this example I was just discussing, where an airline would typically want to hedge jet fuel, but there is no derivative on that. So what they do is they hedge using heating oil or diesel futures. Okay, so you have to get these estimates from historical data. From that you get the age variable that we defined back there, and then using that age you come up with a number of contracts to trade. So this part here is this value here, 37, if what we are using is a forward contract with no daily settlement. If we are using a futures contract with daily settlement, this would be the number. As I said, the numbers are not that different, so it's just a minor adjustment. Okay, let's move on to the next chapter. So this is chapter 5 in Hull. So here it's important to make a difference between investment and consumption assets. So investment assets are assets that are held by a significant numbers of people purely for investment purposes. In contrast, we have consumption assets which are held primarily for consumption, meaning you can do something with these assets, like for example with oil, you are going to use oil to produce gasoline and diesel and so on, right? So for example here, some of these sometimes this distinction is not that clear. For example, you see gold here and silver here, and then you see copper, right? And these are both very similar metals. The point is that copper is used in a lot of production processes for all sorts of electronics and electrical material and so on. So this is actually used to build stuff. We use the word consumption here in that sense as well. Whereas gold and silver, even though there is some applications of gold in microcomputers and things like that, most of the value of gold comes from people speculating. So it's basically just an investment asset. People pay a value for gold which is not related to the value that it has for production. It's a speculative value. So we have to keep in mind this distinction, because as we'll see, the pricing of futures on these underlying assets will be different. Short selling, you probably have heard about this before. In any case, skim through these slides. Okay, so the basic relation here is the formula that links forward prices and spot prices is given by this in the case of an investment asset. In this case, that pays no income, right? So this is the spot. So the future price is just the value that I observed today compounded to the future at the risk-free rate over this period, which is the maturity of the futures contract. Now, if we have an investment asset that provides a known income, then the relation becomes slightly different. In the previous equation, we did not have this term. So now what we have here is we subtract I, where I is the present value of the income during the life of the forward contract. And this example that you have here, it's a typical example. If you did the fixed income course, it's an example we have seen there before, where we compute the forward price of a bond. So now, just a detail here. We can either do the present value of the income like this, or we can transform that through a yield, okay, an average yield during the life of the contract through this expression. And then the formula, instead of being S minus I compounded, becomes like this, where I'm subtracting this yield from the risk-free rate. Right? This gives me the same number on the left-hand side as before. Right? It's just a different way. This Q here is just a different way of writing that present value of the income. Now, for commodities, this becomes relevant because in commodities there is a storage cost, but we can see storage cost simply as negative income. So we can use the previous formula that we had before, just replacing the minus I we had before with this plus U, where U is the present value of storage costs. Okay, so immediately we get this formula, and like we did for the previous case, we can, instead of using this U, we can use a continuous rate for the storage cost like this. Work through these examples. You have the solutions here. Now, for consumption commodities, and again, recall that these are different from investment assets in the sense that people want to have consumption commodities to do something with them, to produce something. The relation between the spot price and the future price becomes less tight. So there is still an arbitrage opportunity if the futures price is too high. But if the futures price is too low, meaning lower than this bound here, then there is not necessarily an arbitrage opportunity. And the reason is that to do arbitrage, the companies would have to sell the commodity to get rid of this. But since this is a consumption commodity, that they may not want to do that because they need it to produce something. So while this we will not observe because there will be arbitrage opportunities, this we may observe. So now instead of a strict equality, what we have is just this upper bound on the futures price. Right? So either written in this form or in this form. Okay? The difference between this price that may be lower than this bound and the bound can be transformed into this yield here. And this is called the convenience yield. It basically means by how much I have to make the bound lower to match exactly the futures price. Look at this example here and this example as well. And that's it.